Okay, so this is P15, Forces and Matter. It's the last topic of the Edexcel GCSE 9-1 Physics specifications, this series of video lessons that I've been doing for you guys. Hope you've enjoyed them. Let's do this final lesson now, okay? So, to stretch an object, two forces must act away from each other. Okay, pretty simple. Okay, obviously if you've got a rubber band, in order to stretch it, you move your fingers in opposite directions. To squash an object, two forces must act towards each other. Okay, pretty straightforward. If you want to squash a sponge, you obviously squeeze it from two ends. And to bend an object, two forces must act towards each other, but not in the same line that they do. Okay, so if you're bending a wire, you know that you still apply the forces towards each other, but not towards the middle. Okay. If masses are hung from a material, okay, that material will extend. And if it does, we call it elastic when those masses are removed, okay, and it goes back to its original length, okay. So you know for a rubber band that if you do stretch it, it will return to its original position or its original length when you remove that force. However, the rubber band can become inelastic when you do remove that force, it does not return to its original length, so that it becomes permanently stretched. So we say materials that are inelastic are when that force has been removed, it obviously will not return to its original length, okay? And there is one practical that you can do. It's called the Hooke's law practical, okay? And it's essentially hanging masses on the end of a spring, okay, and this is a useful equation that you will need to use for that experiment, and it's equal to, so force is equal to the spring constant, which is the K, times the extension, okay. Here E is extension. Sometimes you will see it as an X or an L, but just make sure that you know E is extension, and its units is meters. F is obviously the force being exerted onto the spring, which will be units of newtons, and then K is a spring constant, and it has units of newtons per meter. Okay? So that means the spring constant is the force needed to extend the spring by 1 meter. Okay, so that's the definition for the spring constant. It's essentially how stretchy that spring is. Okay, so how strong or how weak it is, or how good it is at stretching. So a high spring constant means the material will be very stiff. A low spring constant means that the material will be very stretchy. Okay, so if we were going to do this experiment, just make sure you're able to describe how you'd work out the spring constant. So obviously you would apply your masses onto the end of the spring, or you would record the extension each time for the mass, which will be that mass times the gravitational field strength, which is 10 meters per second squared, as I've stated in an earlier video. That's going to be your force, and if you plotted force on the y-axis against extension, the gradient would be the spring constant. Or you could put extension on the y-axis and force on the x-axis, and the reciprocal of the gradient, so that's 1 over the gradient, will equal your spring constant. Okay, so just pause the video, just make sure you're comfortable with getting the spring constant from either putting F on the y-axis and extension on the x-axis, or vice versa. Okay, so here we go. This shows us a linear relationship, so as force increases, extension is increasing linearly. Here's a non-linear relationship where, as we see, as force increases, the extension does not increase linearly either. Okay, so just make sure you're comfortable with sketching, plotting points. Common exam questions will give you points to plot. Just make sure you plot them correctly, and then if you have to work out the gradient, make sure you know how to get the spring constant from it. Okay, so the other equation that's quite useful is this one here. This enables us to calculate the energy needed to stretch the spring. So the energy needed is equal to half times the spring constant times the extension squared. Now, what does that remind you of? Well, the force is equal to the spring constant times the extension. So the force is on the x-axis here. So essentially we were getting a force, a K times an extension, or K times an E, multiplied by another extension, okay, which gives us, that's why we get the e cubed here, sorry, the e squared term here, which means, and this half term here means that graphically this is the area underneath this line. It's the area of this triangle. Okay, so it's this length, which is the extension, so that's one of those e's, multiplied by a force, which is another k times e, because force is k times e, and then the half comes because it's the area of a triangle. Okay, so it's half of a rectangle. So this is a very useful equation. Make sure you're able to work out any of these terms if they give you the other two terms in the exam question.